This video is my attempt to share with you how one can set the idle on a Suzuki LS650 and many other motorcycles using an oscilloscope. If you decide to mess with the electrical system of your motorcycle, and especially the high voltage side of the ignition system, it is your responsibility to take the necessary safety precautions to prevent injury to you, others, and property. I assume no liability for your actions. Cheers, and above all, ride safe. Now, I realize most of you do not have access to an oscilloscope, but what the hey. This video was fun to make. Take what you can from it. I've been in electronics since the 50s, and analog and mechanically servoed and digital computers since the 60s. Don't I look it? Over the past years, I've ended up with a few basic oscilloscopes, devices which graphically show what's going on at a point in an electronic circuit in real time. One can use a scope to set the idle on a motorcycle. They aren't hard to set up or read for a simple task like adjusting the LS650 idle speed to specification. On the screen face there are 8 equal divisions running vertically, 4 above center and 4 below center, and also 10 divisions running horizontally, 5 left of center and 5 right of center. The trace is the green line running across the scope. Its resting place is most often set at the middle of the screen, a convenient place for a zero reference or signal ground, though it can be set anywhere on the screen for the user's convenience. On a scope, from left to right represents time, from nanoseconds to tens of seconds. An oscilloscope shows a visual representation of voltage over time. Think of it as a visual voltmeter. Here, I alternately make and break connection to a 12-volt battery. Like a multimeter, you can read volts for any given instant in time, but you can also measure the time duration between pulses. This time interval is called the pulse period. This is how I'm going to use the scope because a spark at the plug is caused by a pulse of electricity. The most common probe used with an oscilloscope is an X10 or ×10 probe. This probe reduces its incoming signal to 1/10 of its value and offers very little loading of the circuit being probed. Therefore, using a ×10 probe will give a very good representation of the signal. The height of the trace above its reference or no signal setting shows the amplitude of the input signal, usually representing its voltage. Here's a 1.5 volt battery using a ×10 probe, with the vertical range set to 0.1 volt per division. Polarity was positive and then negative. Like a range switch on a voltmeter, I can choose what amplitude of voltage is represented per each vertical division. If I select a range of 0.5 volts per division with a ×10 probe, and then I see a trace height of just over 2 divisions, then the waveform's amplitude is about 12 volts. If the waveform is above the trace reference, that's a positive voltage. Anything below the trace reference is negative. I can also choose the time taken for the trace to transit each division. This control is set for 10 milliseconds per division. 6 divisions to the right equals 60 milliseconds in time. I'm going to use the scope to show and set the period of the spark plug's pulses. As I said before, the period of the pulses is that time between the beginning of one pulse and the beginning of the next pulse. That will tell me indirectly how many revolutions per minute, RPM, not RPMs, the engine is turning. Here is what pulse period I must see on the scope to represent an RPM of 1000. The spark voltage on this motorcycle is generated once every revolution. It is just a high voltage, ugly pulse sent to the spark plug. The pulses, for a proper idle speed, therefore, should occur 1,000 times per minute, because revolutions are counted per minute. Since 60 seconds comprise a minute, I divide 1000 by 60 and come up with 16.667 pulses per second. I then divide 1 second by 16.667 pulses to give me the period of time between each pulse. This comes out to approximately 6/100ths of a second, or 60 thousandths of a second, between pulses. This is very easy for a scope to display. Heck, some scopes even compute and display a pulse's frequency on their screen directly, so you'd be looking for a readout of 16.667 Hertz. That's cycles per second for us old folks. Now, although the RPM of the engine will fluctuate somewhat, we can still set the idle pretty close. Now, I need some way to hook up the scope's input to read the high voltage pulses of the spark plug. Physically connecting the scope lead directly to the high voltage spark plug wire would probably destroy the input circuitry of the scope. The high tension lead has a very, very high voltage, in the order of tens of thousands of volts. So I'll use a method called inductive coupling. I'm going to make the spark plug lead act like the primary of a transformer by wrapping a turn of wire around that high tension lead. This will form a secondary winding and will generate a severely reduced voltage output to the input of my scope. To best read the anticipated pulses, I've set up my scope for a DC input, a 10 millisecond per division sweep, 20 volts per division amplitude, and automatic triggering. To prevent potentially burning myself on the hot engine, I've already wound my signal wire one turn around the spark plug wire and then warmed up the engine. And now I've attached my scope to that wire. I only need to attach the scope to one wire to get a decent indication. Here is the scope's presentation. The scope's trigger is set so the first pulse occurs at the left edge of the display. 6 gradicules to the right is 60 milliseconds in time, so I need to set the idle to give me a separation of 6 gradicules between the pulses. Looks like it's pretty much there. Here you see the effect as I adjust the idle screw on the carburetor. Increasing the RPM decreases the period between pulses. Decreasing the RPM increases the period between pulses. Therefore, the period of a repetitive pulse is inversely proportional to its frequency, or RPM. There. I've now set the pulse period as close as I can. And that's it. Well, there you have it. A couple of switch settings on an O-scope, a wire wrapped one turn around the cycle spark plug wire, warm up the bike, set the idle speed to give the correct pulse period on the scope, and you're done. By the way, an O-scope is a good instrument for testing the igniter's output, the alternator's output, and the rectifier's output. There's a few ideas for more videos. Cheers!